of nearly every systems engineer's existence is documentation. And you will find documentation requirements throughout. There's no getting away from it. So in this model that we've taken on here, we've been working with this model for quite some time. And not too long ago, NIST came out with their model of the system security life cycle, and it maps very well to this one, so at least we got validated. So we use this kind of a process to address all the security objectives that we find in the beginning of the process. We find that a lot of things that would normally think about as being end game issues, we need to think about very early on. One of those is the certification and accreditation activity. If you're working for a contractor who's working for the government, or you're working for a government, and not even ours, but any government, they want to certify and accredit that the system is operating in accordance with their requirements and their best practices. So if you wait to the very end to find out what those are, it becomes quite expensive in time and effort to go back in and fix things that you should have known about at the beginning. And so if you engage your certification activity, accreditation activity people early on, you have a better design in the end. So I think I'll just move on from here. So some of the activities that span the life cycle, and most of these are documents, are the information security plan, the policy specifications. Some of the activities that go on are things like the threat and vulnerability analysis. You first do this on paper, and then you may be able to have introduce some tools into the system to do this once you've got some software developed and some hardware designated. Disaster recovery is something that you want to think about early. You want to be able to plan in your system design for disaster recovery or business continuity or continuity of operations, however they talk about it. And then again, as I said earlier, think early on how you're going to dispose of it and how it's going to be operated. So I'm going to go through this system engineering life cycle and talk about break it down into the phases that we saw in the earlier one. So we're going to look at the systems requirement phase here first. So the goal here is to understand the organizational or mission needs. So as a security engineer, software engineer, or a systems engineer, you're going to be working with your customer to determine what their security requirements are in the system. And they're going to do a lot of hand waving. And they're going to say, well, it's got to be secure. And it's got to work. Can't cost a whole lot. And they'll go on and do things like this. So you've got to understand how you actually go to them, talk with them, and find out what their real requirements are. Now, they may write them down. Hopefully they do. They will have given a considerable amount of thought. But as you're reading it, you're going to realize that there's first level requirements, and then there's a bunch of requirements that make up that requirement. And so those are second level requirements. You may have third level, tertiary level requirements. All these need to be documented, verified, discussed with the customer, proven out, and then become part of the design. So that's the system requirements analysis phase of it, and the organizational mission needs are what drive those things. So you may eventually in your career, you will become involved in helping the customer understand what it is he really wants to do. At this time, you are also going to help them define what the certification criteria are. If you're doing this with commercial industries or hospitals or the energy industry, they all have guidelines that they have to follow. And if they don't already, they soon will have certification criteria that they have to follow as well before they can bring a system online. For the healthcare industry, it's based largely on privacy, patient information privacy. So at this point in here, in your life cycle, you're going to start defining what the system functionality is going to be. Again, you go back to the customer, you get from him his objectives, you get from him the environment in which the system is going to work. Is it going to be a shipboard system? Is it going to operate in a system operations center for a utility? Is it going to be the dispatch system for a trucking company? These all have, or freight forwarding, like an ILS type of organization, or the railroad industry where they're bringing goods in from Mexico and carrying them all the way up to the Great Lakes area. The interface analysis occurs in this phase between systems and within the system itself, and generally this phase concludes with a preliminary design review, and this is the customer's chance to feedback to you whether you hit the mark. One of the documents that you have to come up with in this time frame is the system engineering plan. Particularly if you're dealing with the DoD or the intelligence community in any, the Defense Department or the intelligence community in almost any of the governments. I've seen this in France, I've seen this in the UK as well as the United States, that they want to understand what your plan is for security engineering throughout, and it contains things like processes. So if you've got a set of processes, you tailor them to meet the plan. If your customer has a set of processes, you may have to tailor those to meet your objectives and your system functionality. You're going to work with the customer to establish milestones and a schedule, define the certification criteria within the plan, the roles and responsibilities for the customer in his operations mode will get defined in the security plan, because you have to design towards those kinds of goals. Also in the plan, you'll address the interconnection information sharing criteria. Information sharing is particularly important in government kinds of situations and banking and finance industry, and to some extent in the energy industry as well, where you've got roles that you've got information that you have to protect from wide dissemination. In healthcare, it's privacy information. In the energy, it's usage information, billing information. There's a couple of sources where you can start to find ideas of what goes into a security plan. The NIH is one, their Office of Information Technology, and also the NIST, the National Institute of Standards and Technology, has a lot of documentations. In their case, it's SP 800-64 is a good source of this. So it may be part of the security engineering plan, it may be a separate plan. You're going to have something called the security specification and policy. So what are we trying to protect is what we're going to describe in this plan. And so we have assets. What makes up assets? You got something on your tip of your tongue.
Any hardware basically you need to protect?
Right, hardware. Yeah, that's a lot of times we don't always understand that that's part of what we have to protect is the data itself or the information itself. Yes.
Intellectual property. Intellectual property.
Very good. Intellectual property is can be a number of things. It can be the way the system itself is designed. It can be what the system is trying to protect. It can be your processes, your internal processes, your external processes, all make up intellectual property. So you've seen the confidentiality, integrity, availability, accountability triangles and quadrangles. So you probably are fairly aware of what you're trying to do with that. But accountability is oftentimes not thought of at the beginning of a system. People will bring in the idea of how do I account for how it's used and how do I make people accountable for what they've done on the system. And they wait until the end, to the deployment, to figure this out. The earlier you do that, the better, and you should address that in your system specification and policy. And then your customer is going to have a number of defining documents that you have to consider. I think we covered that one. Where do the requirements come from? Well, they can come from information security policies. They can come from non-information security policies. A lot of security requirements are being levied by the SEC on the banking industry and finance industry. They may not look like information security requirements, but that's how you're going to deal with them. Privacy is very similar to information security, and you're trying to protect certain information. You have to consider, or the environment, the threat environment that you're in is going to generate some security requirements as well. So if you're not connected to directly to the internet, you're running a control system, let's say, that's not connected to anything else, then your threat, you don't have much in the way of external threat if it's not connected. But you do have to consider the insider threat. And insider threat might be poorly trained operators. So you get some of your requirements from what happens when somebody fat fingers a command that they're trying to enter on the SCADA system and causes a circuit breaker in Colorado to trip that eventually brings the whole northwest quadrant of the United States into darkness. So those are the kinds of events that could drive security requirements. Mode of operations are things like are driven by the classification of the information that you're handling. Do I have to have my information compartmented, and do I have to show need to know in order to be able to access certain pieces of information on my system? I have to have security requirements